9.2 is still continuing on with all the statistics and probability. And 9.2 actually is really short when it comes down to all the information that's here. There's really three topics, three ideas, three things that they talk about, and everything else is just spinning off of those three. So the very first thing that's in 9.2 that they look at is the multiplication principle. All right, and I'll paraphrase basically what it is for this part. That basically the multiplication principle says that you're going to multiply the amounts of each different group to get the number of choices. Okay, so let's say you're getting ready to go to, Disney World, that you have 4 park choices. You have 3 different choices of hotel stays. We'll just say like on campus, off campus, then I think you have like a campground that you can do. And then from those, I think there's another 4 different types of tickets that you can buy. You get park hopper, you can get the water parks, you can get all kinds of stuff on those. So they would say, all right, if this is how many, this is the number of choices we have for this particular thing, how many different ticket options or how many they say something like how many options or how many choices or just how many different ways can you pair these together, so how many options are possible. And all you have to do is just take these numbers that you have and just multiply them together. So if you've got 4 park choices, 3 hotel choices, and 4 ticket choices, just multiply all that together so that there will be 48 possible 48 different ways you can group these things together. All right, and they'll change the wording up on those. They'll have it be all kinds of different things that you can do. But basically, it could be that it's something for air conditioners that you have, 9 options for a condenser, 3 for efficiency, and 4 for fan speed. Whatever it's going to be, you basically just take all the different groups that you have and you just multiply each of those different choices together to figure out how many options that you have. Really straightforward question, not really anything too weird that they'll do on those kind of questions. All right, and before they get to the other 2 choices that they talk about, they have to mention factorials. And factorial basically is this. It's easier just to show an example. And when they talk about factorials, you'll see an exclamation point. And this is not people that are excited about their numbers. They're not 5, they're not yelling out the number 5. Basically, the factorial means that you start with that number that you're given and you multiply everything with that number down till you get down to 1. So 5 times 4 is 20. 20 times 3 times 2 is 20 times 6 times 1. So altogether, 5 factorial would be 120. If you were doing the factorials together, if you had 6 factorial, that it would be 6, 5, 4, 3, 2, 1 multiplying together. But if you ever happen to do factorials back to back, if you already know that 5 factorial is 120, well, then you can just multiply that one by 6 to come up that would then be 720. Okay, now in most calculators, any good scientific calculator, they'll have that exclamation point on there somewhere. You just have to find where that number is when you go through those. The other thing too, if y'all have a calculator that you're working with and you're not really sure about a button or where it may be on that one, if you want to just let me know what calculator you have. If we can, if you can share your screen with me when you have something there, usually I can help you kind of figure some stuff out when it gets to those. All right, and here's where they kind of get into the second thing that you have to go through, because this is one that if you don't know what the factorial is, it's impossible to do the permutations part of it. But permutations, this is where you've got, 15 things that you're looking at, and you're going to pick 3 out of the group. The biggest thing with permutations is when you talk about permutations, this is where the order is important. Because in a minute we'll do combinations where the order is not important. And basically permutations, this is where if you do something in a B, C order, that is different than CBA. Or if this would be like if you're winning a trophy, if first place you get paid, $100. Second place you get paid $50, and third place you get $10. Well, being first, second, third, it's more important to be first than it is to be third. So that's where, if you did 2, 3, 1, that the order is important on where you want to be on that one. So if the order is important, then you've got to use permutations. If the order is not, then we'll do combinations. But how that they're going to show those, how that they go through permutations. And look at those. It's basically this. They're going to show it in PR. And N is basically your number that you have. If you have 6 different things that you're picking, let's say you've got 6 people in a group and you're going to pick out 2 people. Well, they always put the big number first and then the smaller number second for these. And basically is this, that when you do permutations with where it shows up in PR, you're going to basically take the first number you have, which is your biggest number. You're going to do n factorial there. And then you're going to divide that by, subtract these 2 numbers, factorial for the bottom part there. So if you had 6p2, that'll be 6 factorial over 6 minus 2 factorial, which would just be 6 factorial over 4 factorial. Okay, and a lot of these, when you do the factorials, when you set these problems up, you're going to have a lot of these numbers that's going to cancel each other out. Because if you actually wrote out what these numbers are, 4s would cancel, 3s would cancel, 2s would cancel, and then the 1s would cancel. Would leave you with 6 times 5 on the top, so that would leave you with 30 as your answer. Oh, one other thing, forgot to put back here. Sorry, I'm doing this. If you happen to get a 0 factorial, that's going to equal 1. That's one of those just kind of oddball numbers that you have to kind of know that they have to set for that one. Kind of like when you do exponents, that if you do, some number to the 0 power that equals 1, that you've got to have something to set for here. This one's kind of the same thing. That if you have a 0 factorial, if you were doing, let's say you were doing 8p8 or something like that. Well, that would be 8 factorial over 8 minus 8 factorial, which would get you this. So this is one of those things that if you don't set, if this wind up being 0, this would make an undefined number, which means it wouldn't be possible. So if you happen to go through a problem like this, then basically it's that number over 1, which basically would just be 8 factorial. Yeah, so that's one of those little trick questions that may pop up every now and again. If you have the same number twice here and here, that's basically just going to be that number factorial when you go through and check out your answers there. All right, and again, some calculators will have the NPR buttons, and when we do the combinations here in a minute, they'll have some of the NCR buttons, and it's just a matter of figuring out how those things will work. So again, that's one of those that you may have to just play around with your calculator a little bit just to see, what the answers would wind up being when it comes down to those. All right, if you did 8 factorial, that would be 40,320. Okay, so there's permutations. That's your formula that you're going to use when the order is important. And when you do combinations, that's where the order is not important. And for that one, it's NCR when they talk about the formula. And it's one of those that, now again, it's a little bit easier because of the way we are this summer, that it's an online test, and you've got your notes in front of you that you can use. But if you had to memorize this one, the easy way I kind of remembered these was that if it's NCR, you care about the order. Even today, when I was getting ready, prepping for this class a little while back, that still popped in my head because I was going, been a while since I've done permutations and combinations. And so I started looking at it and I was like, oh yeah. So it was like NCR, that's one where you care about the order when it comes off of it. All right, now the formula for combinations, just a little bit different. Still going to do n factorial over n minus r factorial. But because you don't care about the order, basically you wind up taking out the repeats, that 1, 2, 3, is the same as 3, 2, 1 is the same as 1, 3, 2, which is the same as 2, 1, 3. So you've got all these repeats in here that basically you're going to go back and take out those repeats as well. So it's n factorial over n minus r factorial, just like it was for permutations. But combination, basically you take out the r, and this, it's not necessarily that that's the way it is, but to me, I always think about it that you got to take out the extras, that you've got all these different ways it repeats. And then we've got, so if you're doing 3 numbers, there's 6 repeats you would have here just picking 1, 2s, and 3s. So you have to go back and kind of figure those out. Okay, so let's say it was, you've got 7 people on a team, and you've got to pick 5, and maybe it's basketball players, that you're picking 5 people to start the game, and you've got 7 players on the bench. Well, whether you're number 1 or you're number 5, it doesn't really matter. If you're one of the 5 picked, this would be one of those problems where you wouldn't care about the order, just as long as I'm picked when it comes off of it. So for this one, this would be where you would do 7 factorial over 7 minus 5 factorial times 5 factorial. Okay, and even if you don't have a calculator that will do, again, most of them will have the factorial button on there, so you can do that one. Even if you had to do these by hand, it really wouldn't be too bad, because this would just be 2 factorial. And then 5 factorial would be just count it down, 5, 4, 3, 2, 1. And most of the problems when you do these, you're going to have a lot of numbers that will cancel. So this winds up being 42 over 2, which winds up being 21. So there's 20. So again, if you don't care about the order, whether you're the first person picked or the 5th person picked, if you had 7 people and you were picking 5, there's 21 different unique combinations of the numbers that you can go through where the order doesn't matter. Okay, And then a lot of the rest of the chapter, I'll give you one more problem here real quick. A lot of the rest of the chapter, it's going to just give you different problems, and you've got to figure out, some of the different things that come from it. We'll show you just a couple of different options of some problems that you may pop into here. Even if you get one that's kind of big, let's say we're doing 52P3. And some of the problems that they do, they'll ask for just the answers. Some of the problems, they'll ask you to do a setup problem like this, where you actually have to punch in the different numbers into the formula. So just realize that sometimes you may have to do that, and sometimes it'll just let you give an answer for one of those. Now, from here, it may go back and then give you what the numbers would be. So this one, we'll just go ahead and kind of put in what the numbers are, because 52 factorial is going to be a huge number. I don't think you can put that in an answer box that they would give you. So this would be one from here. You would just work this out. And again, if you were doing this one by hand, obviously we're not going to go all the way down to 0 on this one. But if you do 52 minus 3, that's 49 factorial. If you started going from there, well, everything from 49 on down is where you kind of get the repeat part. So you don't have to worry about the rest of it. That basically this one is 52 times 51 times 50. And then multiply all those numbers together to get that there's 132,600. So if you were doing 52 and you're picking 3 where the order is important, then there's 132,600 different ways you can come up with it. Okay, so they'll give you a lot of permutation practice. They'll give you a lot of combination practice. They'll mix in a little bit of just a couple easy factorials here and there. They'll do some where they do the counting part of it, where you just, you've got this many in a group, just figuring out what's there. And then the rest of it, they'll give you some problems where you have to kind of manipulate around and do some different things that are there. Let's give you one problem here to show you. They may ask you something like this: how many phone numbers are possible when the numbers will start with 2, 5, 6, 5, 5, 5, and then they'll leave you 4 blanks here at the end. I was trying to come up with a question that was similar to this one, and I couldn't get the wording on it quite correct, but this was about the best I could come up with. So let's say you have a phone number where you're given the area code and you're given the first 3 digits. How many different possible combinations can you come up with from this one? And this is kind of spinning off of that first multiplication principle that they were having when you go through this one, because a lot of times people will go, oh, well, there's just 4 numbers, we've got the 4 choices. But basically, you can have repeats in this where you can start with 0, 0, 0, 0, and you got 0, 0, 0, 1. But basically for this one, you've got 10 choices here for the first number. You've got 10 choices for the second, you've got 10 for the third, and you've got 10 for the fourth. Okay, so on the multiplication principle, it says then, well, if you've got all those choices together, you can just multiply everything together, and that would bring you with 10,000. Okay, another question they may ask you, they'd say, all right, well, if you have this one, just to kind of spin off this one, how many choices would you have? We'll say how many choices are possible if the first number cannot be 0. Well, if the first number can't be 0, then basically now you're down to 9 choices. So then it would be 9 times 10 times 10 times 10. So that's 1,000 times 9. So in that case, that would be 9,000. Okay, so there's one where they just kind of, again, still on the multiplication principle, but they kind of throw it out to you as a word problem. That they just make you just kind of think through the problem and kind of figure out exactly what it is that's going on. All right, and then some word problems that they give to you where you have to kind of figure out if something's a permutation or a combination. And this is one actually it's a combination of two things on this one. Actually, we'll just start this on the next page here. We'll say it this way. How many different committees can be formed from 7 teachers and 9 students if it consists of 3 teachers and 4 students? Okay, so this is one where you got a couple things. First off, you have to figure out if it's permutation or combination. All right, and if you're on a committee, as long as you're not getting paid or there's not any kind of special bonuses to being on, the first person, vice president or president or anything like that, as long as you're on the committee, everybody has the same say-so on this one. That for this one, you don't care about the order, so this is going to make it into be a combination. So we're going to have to use NCR for these formulas. For this one, though, you got 2 different sets because you have 7 teachers and you're going to pick 3. And then you also have the students. And we have 9 students and we're going to pick 4. Okay, so if you wind up having 2 different groups on these, in this case we've got teachers and students, you're basically going to multiply those 2 different groups together. So after we do the combination with 7 choose 3 for this one, we're going to do 9 choose 4 for this one, and we're going to take those 2 numbers and then multiply this thing together. So anytime they give you a 2 different groups mixed in a problem, basically do the 2 groups separately and then we'll pull it back together. All right, so if we do 7C3, that is 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial. So everything from 4 down is going to cancel. When we go through those. Same thing when we do the 9C4 over here. Oh, forgot my next part there. Sorry, forgot that one. All right, that's 3. So that's 7 minus 3 factorial and then 3 factorial. Okay, so that's 7, 6, 5, 4, 3, 2, 1. Or 4, 3, 2, 1 times 3, 2, 1. And the 4, 3, 2, 1 will cancel the 4, 3, 2, 1. On this part, 3 times 2 is 6, so that would also cancel that 6. So that leaves you with 7 times 5, which would be 35. All right, when we do the 9C4, that is 9 factorial over 9 minus 5, 9 minus 4, which would be 5 factorial, 4 factorial. And kind of the same thing on this one when you start to cancel. you can cancel the 5, 4, 3, 2, 1 here, 5, 4, 3, 2, 1 here. You have 4 times 2, which is 8. So that would cancel that. That would leave you with, and you've also got 9 divided by 3, so you could cancel that and divide that by 3. So that leaves us what 3 times 7 times 6. That is 126. That's 21. Yeah. So this part we've got 35 for 7 choose 3. For 9 choose 4, we've got 126. Multiplying those two together, that would come out to be 4,410. Okay, now, and again, if you get a good scientific calculator, you can kind of skip all this work that's in the middle, because you can get a good scientific calculator that will just do 7C3. You can punch it in, it'll take you to the 35. You can do the 9C4, it'll take you straight to the 126. So there are some calculators out there that if you do have those, it will help you get to these kind of problems a lot faster than just doing it by hand, because it does take a little while if you have to do it by hand. Okay, and then one of these problems, something similar to this one. I kind of like this one because it showed the difference between where the order is important and the order is not important. Let's say a lottery game has you pick 7 numbers. From the numbers 1 through 13. Seven correct is a $13 million jackpot. Find the number of ways to choose the 7 numbers. Okay, now in this one, they will actually kind of give you a little caveat with this one. So basically, you're picking 7 numbers from the numbers 1 through 13. If you get all 7 correct, there's a $13 million jackpot. Okay, so it says find the number of ways to choose the 7 numbers. And so here's where you kind of get to see the 2 options on this one. Where A, the order is not important. Okay, so if the order is not important, you don't care about the order, so then that means it's a combination. So it's going to be 13, choose 7. So we're going to do the NCR. Okay, so that's going to be 13 factorial over 13 minus 7 factorial and 7 factorial. Okay, I'm going to save us the work on these because this would be one where I had a calculator and I punched this in to get the numbers, but there's your setup for this part. You've got 1,716 possible different groups to pick from. Okay. That as long as you pick the 7 numbers, the order doesn't matter. Okay, if the order is important, in the Powerball, I think when you do these, there's always one number that you have to have. You have to pick that one number. But in this case, we're looking at all the 7 different numbers being important for these. This would be 13 factorial over just 13 minus 7 factorial. All right, if you punch that in, there's 8,648,640 unique combinations of numbers that you could put for this thing. So I always thought that was kind of good because it helps you see the importance of the order mattering versus the order not mattering if you're picking something. Now, of course, the bigger the numbers that you're picking, the more numbers you have that you're picking, makes a big difference. If there were only, 8 numbers here or 9 numbers, that would obviously change this a lot. Or if you're only picking 2 numbers, that would change things a lot when it comes down to it. But that's one that to me it's kind of nice to see how the order is important for the number of choices that you can come up with there. Okay, and everything else in 9.2 is just some variation of those kind of questions. If it's a word problem, you just have to kind of, if they don't do like this one, where sometimes they tell you, one, you're going to do it where the order is not important, and one time you do it where the order is important. Usually the biggest thing you have to do if it's a word problem is you just have to read through it and figure out, okay, is this important or is it not important when it comes down to order? Okay, and that's really the biggest thing that you have to kind of do when you go through those. A lot of the problems it's going to be, they're going to go ahead and give it to you where it is a permutation or it's a combination. You just have to kind of work those out. But some of them, it's just a word problem. There's a few word problems mixed in there, and you just have to kind of go in and figure out, what it's going to be and how to get through those. Okay, so that's everything from 9.2. All right, with 9.3, it's taking everything with permutations and combinations that was there and still working with permutations and combinations. It's just kind of spinning off of those, just showing you different options you can do with permutations and combinations. That 9.3, they said this is just applications of counting. And probably the one thing that they use throughout 9.3 that they come back to for this one is that if you're talking about an event, that something's going to happen, there's some event you're looking for, then you have to figure out, what your sample space is, which they call S. So if E is the event that you're looking for, S is your sample space. The probability of getting that event, again, I think we did the basics on this one a little while back, is the number of the ways you can get that event divided by the number that's in the sample space. And what they're going to do is they'll just give you pretty much in this part of it that I think there was only 10 questions in the homework for this one. It's pretty much just here's some word problems, read through the word problems, kind of figure out what's going on, and use permutations or combinations to plug in these numbers to figure out, the events you have in the sample space, and you kind of put it all together. And it seemed like there were pretty much only about 3 different options of different kinds of problems that you could kind of go through. So we'll show you one of each one of those, of the different problems that you could see, and just let you kind of figure out what was happening there. One of them is quality control. And this goes on with anytime you talk about products, they always have to do some quality control where they test for that nothing's defective, that everything is set up to be what it's supposed to be. That whether it's computers or cigarettes or could be filling up Coke bottles or whatever it is. There's always some quality control issues that I have to kind of look at to figure out what it is. So let's just kind of show you what that's going to be. Let's say suppose you have a batch of 26 cookies. Where 9 are defective. I don't know how you'd have a defective cookie. Maybe it's not supposed to have peanuts in it, and maybe it does because you got somebody with peanut allergies. I don't know. We're just making up something here. Okay, if 7 are sampled, because if it's cookies, you can't have just one. You got to have more than one cookie. See, this is where I'd like to be in class with you to see if anybody's getting any kind of a laugh or at least a little smile on their face or something here. But I can't tell, so we'll just do the best we can with it. I'm just assuming some people are laughing at it. So if 7 are sampled, what is the probability of exactly 1 being defective? Okay, so here's where you've got to kind of get the pictures for what we're doing here. So we have 26 cookies in the batch that we're doing. We're going to sample 7. And again, if you're just sampling cookies, the order doesn't really matter. So the number that's in the sample space that we're doing is we're going to do 26. We're going to choose 7. Okay, and just to save us a little bit of time, this is again where you go back and plug it into your formula. It's 26 factorial over 26 minus 7, which would be 19 factorial and then 7 factorial. Okay, work all that out. We get that there are 657,800 ways that you could sample those cookies. Okay, so that's if you think about the problem before, that's the number that's in our sample space. Okay, so of that we're doing, we've got one of the 9 that's defective. So you kind of have to do this one in little spots here. So there's the first thing is we've got our sample space. Okay, so we're going to choose one of the 9 to be. It said, what's the chances of one of those 9 cookies being defective? So if we pick any one of the 9, that's because we have the 9 cookies that are defective. We've got to pick any one of the 9, and again, it doesn't matter. We pick the first one or the last one. That's going to be 9C1. Well, if you set that up, that is 9 factorial over 9 minus 1 would be 8 factorial. And we've got the 1 factorial. You work all that out, that's going to come out to just be 9. So there's, again, if we're only picking one cookie, there's 9 different ways we can pick the one cookie. It'll be the first one, the second one, the third one, the fourth one. So that one comes out to be really easy when we set that part up. Okay. Since there are 9 that are defective and 17 are good, okay, here's the next part we've got to break down. So since 9 of the cookies are defective, and again, we're picking 26, then that means that 17 of the cookies are good. So of the 9 cookies we had that were defective, we were only picking 1. Of the 17 that are good, we're going to pick 6. So we've got to pick, basically when it comes off this problem, it's a 2-part question. We've got our sample space. We've got 26 cookies. We're picking 7. So there's all these different ways of picking out all these parts that's here. Again, they kind of break it down in parts. We have 1 defective cookie that we're picking out of the 9 defective that we have. So there's only 9 different ways because you're only picking 1. So there's not much options on that one. Since there's 17 good cookies, we're going to pick 6 of those that are good cookies. So we're going to do 17C6. Again, just saving us a little bit of time on that one. If we do that, that comes out to be 12,376. Okay, so kind of going back to our formula then, we've got to have the number of the events that we're doing over the number of the sample space. Well, here's our sample space that we have here. Somewhere here. There we go. So there's our sample space. That's the 657,800. The events that we had, in this case, we've got 2 events. So this is where a lot of the things are different in this section that we're going through, is that you have 2 events. You're going to pick 1 good cookie. Sorry, 1 bad cookie. Get my wording correct here. We're going to do 1 defective cookie. And we have to pick 6 good cookies over all the cookies options that we have here. Well, the chances of getting the 1 defective cookie then is going to be the 9. The 6 good cookies we're picking from, that's the 12,376. And that's going to be over our sample space of 657,800. Okay. Now, sometimes what they may ask you on this one is they may ask for it in 2 different parts. They may ask you how many different ways, because it's asking for the probability, and it's going to tell you at the end that when it asks you the question, which is a probability, we've got to go back and take, multiply this number together, which would be 111,384 over the 657,800. They could ask you for how many different ways can you pick, how many different choices are there to pick the 1 good, the 1 defective cookie and the 6 good cookies, or whatever it is asked for. So there's 111,384 ways that you can pick this thing out where you only get 1 defective cookie. And then probably the second thing that they're going to ask for in some of the cases then is, all right, now based on that there's this many options that you can pick from out of the 657,000, what would this probability be? So that's where you then go back and punch in the calculator, and they'll tell you to round it to 3 or 4 or 5 decimal places. Every time I looked at different problems through these, they were always all different numbers, so you just have to pay attention to what it is they ask for. For this one, we're going to round this off to 4 decimal places. So the probability is 0.1, or about 17%, really is what it comes down to. So there's a 17% chance that you're going to get 1 defective cookie. Okay, so there's one of the options they do. And every quality control type problem where you're doing something along those lines is basically going to be that, where you have 2 different events that you're looking for. You've got part that's good and then parts that's bad, or defective and non-defective, or how they want to say that. So it's just taking out the different pieces of what you have to do. Okay. The other one that they may throw at you is dependent events. And this is where, one thing depends on the next thing. Every time you do something, it could be a card problem where you draw a card out of the deck, and you don't replace it, and then tell me what the probability is that, you get a king the first time and a king the second time and then a queen the next time, so that you're taking the numbers are going to change, basically is what it comes down to. Do something like this. Let's say that there are 11 $50 winning tickets. We'll say that there are 14 $25 winning tickets. There's 10 $5 winning tickets. And then 20 that are basically no winning tickets. Dummy tickets, losing tickets, whatever you want to call it. Basically, you get 20 tickets that don't have any winnings at all to it. So they'll give you some kind of setup here, and they're going to ask you then to find the probability of, and they'll give you some combinations of some of these events, whether it's, what's the probability of getting a $50 ticket, a $25 ticket, and then a $5 ticket, or whatever the case may be. They're going to throw something at you here. For this one, let's say find a probability of 3 $50 tickets. Okay, so very first thing you want to do is we've got to get a total to know how many tickets that there are. So add these together. There's 20, 30, 40, 50. Looks like it's going to be 55 tickets. Okay, so if it was one $50 ticket, they said, what's the probability of getting one $50 ticket? Well, you have 11 tickets out of 55. So if it was just finding one $50 ticket, it'd be 11 out of 55 or 1 out of 5. If we simplify that down. Okay, so that'd be the first one. If they say, all right, what's the chance of drawing 2? Well, if you've already drawn one of these tickets out, now there's not 11 left over. Now there's 10 winning tickets left over. You've taken one of those out now, so instead of having 55 tickets, now you're down to 54 tickets. So that's for your first ticket. This would be for your second ticket. And then if you get one more $50 ticket, well, same thing. Now you're down to 9 tickets that's there. You've already drawn out 2 of them, so now you're down to 53. Okay, and this is one of those problems that if they give you this one, they're not going to ask for each individual piece. We're just kind of showing you for these of what it would be. And then they're just going to ask you what would this probability rounded off to 3 or 4 or 5 decimal places, so that you just basically go back and multiply all these numbers together, divided by all these numbers, and then come back and tell me what that would be. And again, we're going to go 4 decimal places, so that would be 0.0063. Yeah, and again, they could change those numbers around. It could be that they may ask for, what's the probability, if we did it real quick underneath here. They may ask for what's the probability of, one $50 ticket, one $25 ticket, and then one $10 or $5 ticket. Well, first one would be the same thing. You would start with 11 out of 55. The next one, there's only going to be 54 tickets because you've taken the one ticket and thrown it out. If you go for the $25 ticket, there were 14 of those. And then the next time, there would only be one more ticket is out, so now we're down to 53 tickets. The $5 tickets, there were 10 of those. And then you go back and multiply all those numbers together. Yeah, so if it's a dependent events, those are, to me, pretty straightforward because you know that numbers have to go down here, and depending on what they pick from you here, you just go back to your, the number of tickets that you have, and if you pick two out of the same group, then these numbers will decrease. If you pick one out of each different group, those numbers will just be what you had here. So it's just a matter of reading through the question and seeing what it is that they're going to ask you to do. Okay, and then the last problem that of the types they give to you. This one will say that there's 20 applicants for a position. And we'll say that 10 are ages 20 through 39. 6 are ages 40 through 59. And 4 are ages 60 plus. If 9 are selected at random, okay, and this is one where it's kind of like the last one. They'll give you some different options what to do here. Find the probability that all are ages 20 through 39. Okay, so we've got 20 applicants. We're going to pick from the options of everything that's here. So out of the 20, we're going to choose the 9. They're there. So for this one, basically just kind of go through. We'll plug in the numbers and so this is our choices that we're picking from here. So we've got 20 of them. We're going to choose 9. So that's our sample space. Okay, if we're picking of the ones that's ages 20 through 39, again, this is one where, because the order doesn't matter whether you're picked first or whether you're picked last, everything that we're going to do is going to be a combination. So the 20 choose 9 is our sample space that we're looking at. Okay, to find the what they're asking for, find the probability that all of them are ages 20 through 39. Well, we have 10 people, and we're going to choose 9 of those people. And again, the order doesn't matter, so it's just 10C9. So we're, of the 10 people that are ages 20 through 39, we're going to pick any of those 9. That's our events that we're looking at over our sample space. So that's kind of going back to that one fraction that they were talking about way back when that we were doing back in section 2. So this one they're actually going back into section 2 and kind of pulling this problem out. Okay, so punch in those two. And again, those are going to be 2 really big numbers, so that's one where you definitely want a calculator that will do this for you. Punch all that in. I think this one you have to go out to 5 decimal places because the number is so small that if you don't go to 5 decimal places, it doesn't show up. So for this one, it's going to be 0.00006 that you get all 9 picked would be in that age group from 20 through 39. So that's a pretty small chance of all that happening there. Okay, so for part B, let's find the probability that 5 are ages 20 through 39, and 4 are 60 plus. Okay, and this one is going to be a two-part problem because you have two events. You've got to have the event that you're picking 5 from the ages 20 through 39, and then you got 4 from the 60 plus. So there's actually two events that we're looking at for this part. So we got event 1 and event 2. All right, our sample space is still the 20C9. That's not going to change. That's still going to be the same thing for this problem. Okay, so for event 1, we're picking 5 ages 20 through 39. And there were, back up here, there were 10 people that were between the ages of 20 and 39. We're picking 5. So we're going to do 10C5. For 40, there were 4 people that were picking, and there were only 4 people in the group. So that's going to be a 4C4. Okay, so we're picking everybody out of this group and half of this group to kind of get there. Okay, and again, those numbers are going to be big, so there's no way I can kind of really show that here. This is one where you definitely want a calculator to go back and find out these different numbers. And depending on the calculator, sometimes you may have to find out what this number is and write it down, find out what this number is, write it down, find out what this number is, write it down, and then punch it all in. Some calculators will actually let you punch in each little piece and section, and you can do it as a fraction. So it just depends on the calculator you have and what it will let you do. But if you do this when you punch it all in, this should come out to be 0.0015. Okay, and then the last one here, this is where they get a little bit sneaky. We're going to find the probability that 4 are ages 40 through 59. Okay, so we know the sample space is going to be the 20C9 because that's been that's our sample space for every single one of these questions that we're going to do. Okay, so we're finding the probability that 4 are ages 40 through 59. So there are 6, and we're going to choose 4. Okay, and that's it. Now, here's where they kind of get a little sneaky with you, because you either have the 4 who are going to be ages 40 through 59. Anybody else that's not 8, we don't really care. So basically, these are the ones that are between the ages of 40 and 59. The other group is everybody who's not in that group. Because we don't really care. We don't care if they're 60 or 100 or 2 or whatever the case is. Basically, it's everything else that's left over. So if you take everything out, if there were 6 of them out of the 4 that's here, well then if 6 of them are, and then there's 20 out of the groups, that means there's 14 of them that are not. If there's 9 of them here, we're picking 4, then that means there's going to be 5 that we're picking from that group. So if this is the yes and the no's, basically, again, the shortcut is if you know how many you have in the group, you basically can just subtract these two numbers. So we've got 20 minus 16 for the 14. On the right side of it, 9 minus 4 will give us 5. All right, and then same thing. You just take all this, punch it in your calculator, work some numbers, and this one comes out to be a little bit better, actually a lot better percentage-wise. It would be 0.17879. So that one you'd have about a 18%, move that over 2 decimal places, about an 18% chance of getting 4 out of the 6 that are between the ages of 40 through 59. Okay, and everything else is just some version of those kind of questions, whether it's a quality control issue or it's just dependent events, or in this case, you've got picking applicants from a pool. But I think the biggest thing on these is a lot of these problems is just figuring out the events in the sample space. That if you can kind of get going back to the section 2 when we first started with it, is that if you can kind of get back to that option of we're doing an event in the sample space. If you can get back to figuring out the events in the sample space, that's really kind of where everything else is going to spin off on these questions. So, okay. And again, I know we're finishing early, but that's really all that they can throw at you in these sections. Everything else would just be some version where they just change the wording on it a little bit. But that's pretty much all the options that we can go through there. So if y'all don't have any, I'll just hang around. If y'all got any questions, if you want to hang around for a few minutes, I'll answer those. If you don't have any questions, then you are free to go. Y'all have a great weekend.